All right, so section 2.4. So we're going to be looking more at the derivative, and really for the rest of this course, we're going to be looking at it's called the derivative. So we introduced this in the last section, but just to kind of recap, conceptually, the derivative is just the slope of the tangent line at a point on the graph. So if we're looking at this one that we're about to do, and we wanted the derivative of that point there, what we're talking about is the slope of the tangent line. The tangent line is just the line that comes down and touches the graph at that one point. And so we related this back to average rate of change. We can look at the average rate of change over an interval, and then we can shrink that interval down to where we're just looking at a particular point. And so this formula here, the derivative of a function at a fixed number a is given by this formula. And of course, this is the difference quotient. We take the limit as h goes to 0. If we replace a by a variable x, we can get f prime. So that was what we called this notation here, f prime, which represents the derivative of x, and then we just replace the a with an x, and now we have a function that represents the derivative, and now we can figure out in whatever curve we have, we can figure out the slope of that curve at any particular point, provided it exists. We'll see sometimes it doesn't. See that probably in a later video. But like I said, we call that f prime. That's the derivative of x, and again, derivative just means slope. So whenever we talk about derivatives, we're really talking about the slope of the function. And of course, with curves, the slope is always changing, and so that's why this can be interesting. It can be useful because it's always changing, and it's always usually of use to know. So a function is called differentiable at a number if the derivative exists there. And then, of course, we can say, so that's at a point, we can say it's differentiable on an interval if the derivative exists at every number in that interval. So, so like this function is differentiable on its entire domain that we can see there. All right, so this first example, the graph of the function is given below, and we want to sketch a graph of the derivative. Now, I remember when I first took calculus, this was probably about the hardest thing for me. And probably, I would guess, because I did not understand exactly what the derivative was talking about. So a couple of things to look at when you have to sketch a graph of a derivative. And you could also do this vice versa. We could give you the graph and the derivative, and you could sketch the function. But the first thing to notice is where is the graph of the function changing directions? So we see at these 3 points, it's going from decreasing to increasing, and then increasing to decreasing, and decreasing to increasing. And so what we know, so these are tangent lines that I've kind of drawn here, and they are all horizontal. And so what that means is f prime of whatever those values are would be 0. So at all 3 of these points, f prime would be 0. So if we are drawing the graph, I'll try to make this kind of the same scale here. So we'll put 1 there. What we know about that is when the derivative is 0, the graph will be flat, or at least it may not change direction. We can see examples where it doesn't necessarily change direction, but the tangent line will be horizontal. So let's just say we'll call that point A. We'll call this point B, and then we'll call this point C, just so we can kind of see where we're looking. So A, B, C. We know that the derivative, so this is the graph of the derivative of f of x. And so if the derivative is 0, wherever we have the horizontal tangent line, or wherever the graph is flat. So we know that the derivative at those points will be 0. Now, what can we say about the points in between? Well, the graph is decreasing here. So that means that the slope is going to be negative. So that means that the derivative is going to be negative. So if the slope is decreasing, or sorry, the function is decreasing, that means the derivative is negative. And now, how do we know it's coming up or going down? What is it doing over here? Well, really all we know is for now, is that it's coming up to this point. We know it's going to touch there. Then it's going to be increasing. So we know it has to be positive between A and B. And then it's going to be decreasing between B and C. So that means the derivative has to be negative, and it's going to come down and back up like that. And then it's going to be increasing. So don't worry about, and this is one thing that you can kind of get hung up on. The F is negative in this interval here. So from there to there, F is negative, but that doesn't say anything about the derivative. You cannot say anything about the derivative based on the value of this function. The only thing we're looking at is the slope. We know that between B and C, the slope is negative because we're decreasing. So that means that for the entire area, the entire interval between B and C, the derivative has to be negative. Now, how far down does it go? Maybe it just kind of goes like that. That doesn't really matter. We're just kind of looking at, is it positive or negative? And so then after C, it is going to be positive, and we'll just draw it like that. We can talk about a little bit more, what's going on in this. We may talk about that at some point, but for now, just kind of make sure that if this is increasing, the derivative is going to be positive, which means above the x-axis. If it's decreasing, the derivative is going to be negative or below the x-axis. Don't worry right now too much about specifically what is it doing. Just make sure you get the positive parts and the negative parts, and you should be pretty good for now. Now we can also look at a table, and we can kind of get an approximation. So don't worry about this table here. This is actually the answer, and there you can see the reason I went ahead and put this up is just because there's a lot of calculations. So just to save time, I went ahead and put this up, but this is kind of what we're figuring out here. So just pay attention to this table. This is what we'd be given. So B of T is the number of E. coli bacteria cells present after T hours. The T on the left gives values of B of T for the first 20 hours. So we're going to construct a table for the derivatives, and it's already done. I'll do a couple of them, and then you can kind of work through the rest and make sure you get the right answers. But essentially, let's just pick 14. Let's find B prime of 14. So the way we do this in this particular case is we're going to find average rate of change from 14 to the value before it, and average rate of change between 14 and the value after it. So B of 14 minus B of 12 over 14 minus 12. So that would be 429.5 minus 278.3, and then over 2, and let's see what we get. So we get 75.6. And now we're going to do the same thing with 16 and 14. And so B of 16 is 541. B of 14 is 429.5. And then 16 minus 14, of course, is 2. And we get 55.75. And then what we need to do to get actual B prime of T is just average these two together. So 75.6 plus 55.75 over 2, and that gives us 65.68, which is B prime of 14. So that's how you get it. You can do this with any of them. And we'll mention the way to get these ends, because obviously there's nothing before 0. There's nothing given after 20. So the way to do that is you just look at these. So find average rate of change between these two, and that gives you the derivative at 0. Find average rate of change between these two, that gives you the average or the derivative at 20. So for instance, 3.1 minus 1.1 is 2. So then 2 over that difference, which is 2, of course, gives us 1, which is b prime of 0. For all the ones in the middle, you got to do it like we did here, where you find average rate of change from the two prior and then the two after whatever point you're looking at. So that's more just kind of give you an idea. This is not anything that is going to come up a lot, but this is just kind of get you used to the idea of the derivative and what it's talking about. All right. I think that's enough for this one, and we'll continue on the next video.